Before we start actually working with the examples and building code that works with files, let's take a look at some of the important file API interfaces that we're going to be working with. The first interface is called a blob. And a blob is simply a contiguous amount of raw data, whether that data is text, an image, a bunch of PDF, some Photoshop file, doesn't matter. It's just a certain amount of data that's in a contiguous byte stream. There are three properties here. There's the size property, which is the size of the blob in bytes. There's the type, which is the MIME type of the blob, and that's either text plain, image PNG, whatever the MIME type is. And then there's a slice function. Now, we'll work with slices later, but basically slice returns a new blob object of the given range of bytes, and optionally you can specify a MIME type. Now, you won't work with blob interfaces directly. What you'll typically use is the file interface, which inherits from the blob interface. And file actually adds a few other properties. Now, this represents an actual file, whereas the blob represents a just set of data. The name property represents the actual name of the file, and the last modification date specifies when the file was last modified. So using this collection of information, you can find out a lot of cool stuff about a file. What its size is, what its type is, what its name is, and so on. There's also the file list interface, which is what allows us to work with multiple files. It represents a sequence of one or more file objects. And again, you won't work with the file list interface directly. You'll just operate on it as if it were an array. There's also the file reader interface. The file reader interface contains the actual methods that we'll use to read the contents of a given file. Now, for security reasons, the user has to have some interaction in the process by selecting one or more files to read the data from. You might be wondering if it's possible to get a reference to a file and then save it somewhere like in local storage or a cookie somewhere, and the answer is no. And the reason for that is for security reasons. You can't just simply get a reference to a file, store it aside, use it later on. The user has to be involved in the process in selecting the files. So there's no way to store a path and then read it later. And of course, the file reader comes along with some interesting properties and functions. The ready state function is very similar to Ajax if you've ever used it. It indicates that the reader is either empty or loading or done. And we'll see examples of that later. The result property contains the contents of the file that have been read so far. And we'll see what that means later on. In other words, you can actually read the entire contents of the file at once, or you can read a portion and move through the file in chunks. The error property contains any error code associated with the current read operation. And then there's four methods. There's read as text, read as data URL, read as array buffer, and read as binary string. The first two are pretty self-explanatory. Read as text reads the file as a text file. Read as data URL returns the file's data as an encoded data URL, and typically you'll use that for images. Read as array buffer and read as binary string read the data buffer as either an array of bytes or a string of binary data. And those are fairly advanced, so we're not going to be working directly with those, but just be aware that they are available to you. There's also the file error and file exception interfaces, and these contain any error information about the read process. The file error interface is used for asynchronous reading, while the file exception is used for synchronous reading. And we'll be working with both file error and file exception. Now, there's a couple of error codes that you can use in here. Not found error security. Again, these are pretty self-explanatory, and we'll see how to look at error codes later.